Welcome to another series of EPEVER video tutorials. Today, we will introduce the HP Series 20SA, our most advanced charging inverter. This video provides a detailed tutorial on setting up single-phase parallel configuration. Whether you're a professional installer or an enthusiast in renewable energy solutions, this guide will walk you through the process, ensuring a smooth and efficient setup. So let's explore the capabilities of the HP Series 20SA together. The HP Series 20SA is a cutting-edge inverter charger featuring pure sine wave output, compatible with various generator types for charging. It includes an integrated BMS link module and a historical data record function. This device is capable of managing multiple energy sources and supports both single-phase and three-phase parallel output in a fully digitalized format. In the following sections, we'll walk you through the procedure for adjusting the device's phase settings and show you the method for implementing single-phase paralleling. Topics covered include set device phase and battery connection modes, connecting input and output wires, linking parallel communication lines. Our standard configuration allows for the parallel output of up to 12 devices. Customization options are available to increase this number if required. For single-phase parallel operation, at least 2 identical devices are needed. Up to 12 devices can be operated in parallel. The method of parallel connection is illustrated in this diagram. We will use 3 devices as a model to demonstrate the single-phase parallel setup. These are from the HP HP 0650P20SA series, alternatively known as HP Series 20SA. Each device features a front-mounted LCD screen and 5 control buttons. The communication interface for multi-device parallel connections is situated on the left side of the product, with input and output interfaces located at the bottom. Before making single-phase parallel input and output connections, it is crucial to power each device separately and set up the phase and battery connection mode. This involves opening the wiring cover of the device, connecting the ground wire, attaching the battery, and turning on the device switch. Connecting the ground wire. Attaching the battery. Turning on the device switch. Once the device is operational, you can proceed with configuring the phase settings and battery connection method. Phase setting and battery connection are software-based tasks, accomplished using the device's front screen interface. To begin, long press the Enter key to access the administrator interface. Next, press the Enter key 4 times in succession to enter the administrator password, 0000, which will take you to the BMS data interface. Then, press the Enter key twice to navigate to the Set Data Navigation interface. You can complete the phase setting and battery connection method in the 2nd, load, and 5th, basic, options respectively. We'll now demonstrate these steps in detail. Use the down key to select the load option and press Enter to enter the load setup interface. Continue using the down key to reach the phase set option and press Enter to enter the phase set interface. You can see the phase of this device is phase A. Since we are setting up the devices for single-phase parallel output, it needs to be set to single. To do this, use the up key to navigate to single, then press Enter to confirm. After success, press ESC to return to the Setting Data Navigation interface. To configure the battery input mode, first use the down key to select the basic option, then press Enter to access the basic input mode interface. Continue pressing the down key until you reach the last option, BAT input mode. And press Enter to enter its settings. In this section, you'll find two options for battery input modes: shared, independent. The shared option indicates that all devices participating in single-phase paralleling use a single shared battery group. The independent option means that each device in the single setup must use a single battery group. It's crucial to ensure that the battery input mode setting corresponds with the actual connection method of the battery bank. Incorrect settings can lead to device damage. Considering cost-effectiveness and ease of use, we recommend the shared input mode. Additionally, our demonstration will be based on using the shared input mode. Proceed to set the shared battery input mode by pressing the up key, navigating to shared, and then pressing Enter to confirm. Subsequently, press ESC multiple times to exit the settings. After this, turn off the device. Wait for more than 10 seconds before turning the device back on. Repeat the steps you've previously followed to verify the phase setting and battery input mode of the device. Ensure the phase set is correctly set to single and the BAT input mode is set to shared, indicating that these two settings are configured successfully. Press ESC to exit and then power off the device, removing the battery. For the remaining two devices, apply the same process, setting their phase to single. Ensure the battery input mode is consistently set to shared across all devices. Power on these devices again for confirmation. After successfully configuring the phase and battery input mode for all three devices, you can proceed to wire the single-phase parallel input and output connections. The steps for single-phase parallel input and output wiring are as follows, as shown in the diagram. Protective earth connection. Start by connecting the ground wire to each device individually. Battery bank connection. Connect all devices independently to the same battery bank. It's important that the wire gauge and length from the battery bank to each inverter are identical to ensure uniformity. Load connection. First, connect the neutral wire, N wire, of all devices to the busbar, then connect the combined neutral wire to the load. Next, connect the live wire, L wire, of all devices to the busbar, then connect the combined live wire to the load. The wire gauge and length for each inverter's connection to the AC load should be the same. Solar panel connection. Each device should be individually connected to solar panels. The total output power, wire gauge, and length of the solar panels for each device should be equal. Utility power connection. Connect the utility power to each device, noting the following points. First, connect the utility power's neutral wire to the busbar. Then, from the busbar, distribute 3 neutral wires to connect to each device's utility power end connection port. Then, connect the utility power live wire to the busbar, and after distribution through the busbar, connect the utility power live wire to each device's L connection port. The wire gauge and length for the grid power input connection lines to each inverter should be uniform. Parallel communication system installation. Install the parallel communication resistor with a male connector on the device 1. Use parallel communication lines to connect the device 1, device 2, and device 3 in sequence. Install the female connector with a parallel communication resistor on the device 3. To avoid communication interference, please ensure that the parallel communication lines do not overlap with other wires. Important note: for the selection of wire gauge for all the above connections, refer to the guidelines provided in the user manual. As we move on to the practical aspect of wiring, please heed the following warnings. Wiring steps. Connect the ground wire to establish a safe electrical system. Connect the battery bank to provide power storage. Connect the load to distribute power. Connect the solar panels to harness solar energy. Connect to grid power to integrate with the main electricity supply. After completing the input and output wiring of the devices, remember that the system cannot yet output power after single-phase paralleling. This is because the three devices are not yet communicating in parallel. To resolve this, install parallel communication lines and communication resistors in the devices. The parallel communication line, featuring one male and one female end, connects two charging inverter devices. Attach the male end to the device's female interface and the female end to the device's male interface. A pair of parallel communication resistors consists of one male and one female resistor. Install the male resistor in the device's female interface and the female resistor in the male interface. Remember that these items are non-standard accessories and must be purchased in advance for three-phase applications. For the demonstrated single-phase parallel system involving three devices, prepare two parallel communication cables and a pair of communication resistors in advance. The figure shows how to install parallel communication for this single-phase parallel system. The steps for installing the parallel communication system are as follows. Install male communication resistor. Attach the male communication resistor to the female interface of device 1. Connect devices 1 and 2. Use the first parallel communication line to link device 1 with device 2. Connect devices 2 and 3. Utilize the second parallel communication line to connect device 2 with device 3. Install female communication resistor. Fit the female communication resistor onto the male interface of device 3. To avoid interference, ensure that the parallel communication lines do not cross with other lines, such as PB, battery, or grid power connections. For setups involving more than 3 devices in single parallel, like 5 devices, just use additional parallel communication lines to connect them in sequence. Actual installation of communication lines. Install the male communication resistor on device 1. Connect device 1 and 2 using the first parallel communication line. Link device 2 and 3 with the second parallel communication line. Install the female communication resistor on device 3. After completing the parallel communication installation, your 3 single-phase parallel devices are ready. Before turning on the devices, double-check that all wiring is correct and secure. Once you've verified this, turn on the devices. You should see SM3, SS3, SS3 on the display. S indicates the 3 devices are for single-phase parallel output. M represents the master device. S represents the slave devices. The number 3 indicates there are 3 single-phase parallel devices online, matching the actual number of devices. The three devices have now successfully completed single-phase paralleling and are ready for use in a residential setting. Remember, safety and precision are key, so always refer to the user manual for specific guidelines. If you